Alright, this is a video on how to replace null values in a Pandas DataFrame. So in this case, we're going to import a couple libraries, so we'll start there. We're going to go ahead and import Pandas, and we're going to import as PD, and we're going to import NumPy as NP. If you're not familiar with the as text here, what I'm doing is replacing the Pandas library name with PD. So every time I type PD, I'm accessing the Pandas library. For every time I type NP, I'm accessing the NumPy library. So we'll go ahead and run that and import our libraries. Once I have the libraries imported, what I need to do is import my data set, and I access this data set from the Kaggle website. This is going to be the Titanic data set, which is a very common kind of entry-level data set. I'm going to use the Pandas library, and I'm going to use the function read_CSV, which allows me to import the CSV file, which I have designated in this directory. Notice that there's a train.csv, and then just below that is a test.csv. Kaggle has actually separated out the data set into training data and testing data. I'm going to go ahead and save those as train_df for DataFrame and test_df. Additionally, what I can do is concatenate them together using Pandas. So pandas.concat allows me to put these data frames together into a full data frame if that is at all useful. You probably don't need it here, but it's there just in case you want to try that. So I'll go ahead and run that and import my data, and the first thing I'm going to do is kind of explore my data. So I'm going to explore specifically my training data set. That's the one I'm going to be working with. That's the one I want to familiarize with myself first. So when I go ahead and use the .head, that will give me the index for the top 5 rows here. I have all of the column names or parameters or variables, if you want to call them that. You have passenger ID, survived, passenger class, name, sex, age, etc. You get to see kind of just general idea of what sort of data is in each column as well, which is very helpful. If you go ahead and use your DataFrame.columns.values, this will also give you a little printout of each of the column names just to make sure that we're looking at all the columns here. Then I want to actually use, I want to see which columns might have some missing data. So specifically, I want to explore, which values are missing, what I want to do with them. So this .info function will allow me to see that. So the very first thing you'll see range index, it has 891 entries. That's telling me the total number of entries I have. So when I look at this table here, and under non-null count, if it says 891 non-null, it means I don't have any missing values. But if you jump ahead here to age, you have 714 non-null. What that's telling you is you have about 200 to 300, if you do the math in your head, missing values. So you have quite a few missing the age parameter. And if you keep going down, you have a whole bunch that are missing the cabin parameter, and then just a couple that are missing where they embarked from. So this gives us an idea of where to start. So specifically, we're going to aim at age for this video. When we get to cabin, we're going to get a little bit deeper into what to do with that, just because there's so many missing, and because there might be some covariance involved. So we're going to go ahead and look at age. We have 714 missing. So the first option we have is we can remove any row that has any missing data. So using the drop NA, that'll just drop all missing values, and it literally drops the entire row if it has any missing values. So let's see what that does. So when I run that, I'm left with 183 entries. So that's problematic because we went from 891 to 183. We've lost 80% of our data. That's probably not what you want to do. If you got enough data, maybe that's fine, but in this case, probably not what we're looking at. So what we probably need to do is look at it column by column. In this case, we're looking specifically at age, and we got some ideas. If it's numeric, maybe we use the average or the mean. If it's binary, maybe go with the mode. If there's a bunch more ones than zeros, maybe go with 1. Maybe go with an in-between number like a mean. Maybe we'll figure that out later. For text, maybe it's useful just to put none or not available and use that as its own category. And then finally, you need to ask yourself, if I did change something about a missing value, do I need to add another column that will designate whether or not I changed it or whether or not it was originally missing? That might be useful in the future. We're not going to do that here, but perhaps that's something you need to consider. So again, let's look at our original data. Again, we're looking at age is our first missing column. So let's go ahead and look specifically at that. So we're going to get our mean value. It's just under 30. You got 29.699. We got a standard deviation. You have your minimum and your maximum. You have your quartiles there. And let's go ahead and look at the histogram as well. So to look at the histogram, you go ahead and pull up just that column using the .loc function call here. You use square brackets. This will give you all rows under just the age column, and then use the .hist to actually pull up the histogram. So we've got a little bit of a tail here, but you can clearly see the average value underlying just about 30 there, and you get a general idea of what's going on. Compare that to the previous data frame where we actually removed all of the null values. We can look at it again, and you can see that mean value has shifted almost 10 years. It's somewhere near 40 there, 35, 40. So a few things. First off, that clearly changed your data. And then it also means that a lot of these NANs or null values are probably young. It doesn't mean that they were missing the age parameter, because clearly that was affected when we removed it, but it was missing under the cabin. Many of the missing cabin values were younger passengers. So that's kind of insightful as well. So now what we're going to do is actually we're going to fill in the null values under the age parameter with the mean value. So what I'm doing here is I'm creating a new variable. The reason I'm doing that is because I don't want to replace, I want to still work with my original data set. And again, I'm using that .loc, pulling in all my rows under the age column. .fillna, this will fill all nada numbers or not availables. And I'm going to take the age column mean. So I get that column name, train df under age mean. That'll give me the mean value of that, and it will replace all missing values with that. So when I go ahead and run that, you can clearly see our mean value did not change. It shouldn't have changed. We used more mean values, so it actually should be more resilient to that mean value. We're back to all of our counts. We have 891. We have a standard deviation that has shrunk, so now we're down to 13. If we scroll up, we can see originally we were at about 14.5. Our minimum value is still the same, so we didn't change the minimum value, nor did we change the maximum value, but you will notice the quartiles have changed. So now that 25th percentile, we have 22. Originally it was 20.15, so it's gone up a little bit. For the 50th quartile, we have 28. And now we're up to 29.6, so it's increased slightly. So we've shifted up a little bit there. And then finally for that 75th percentile, we have 38, or we were at 38, now we're at 35. And it's shrunk down just a little bit, specifically because we've gotten more mean values, so it's centered in more towards that mean, and our histogram itself has kind of thinned out because we've added more values on that mean. So finally, let's go ahead and look at that histogram, and you can actually see that. So now you have a very high peak value right around that mean, and the rest of the histogram has kind of zoomed in a little bit or shrunken in a little bit. Anyway, I hope that was helpful. In my opinion, I just put this note here. This seems like a reasonable change for age, that we put the mean value. It doesn't alter the mean at all. It squishes the data in a little bit. Whether or not that's appropriate is up to you. We could potentially run a few tests to really test that out, but just from my naked eye here, I think that's probably a reasonable change, and that's a pretty easy solution for the age. When we get to cabin, which is the other big one, that's going to be a little bit trickier. So we're going to have to kind of think about that a bit further, and we'll cover that in another video. Anyway, I hope that was helpful, and we'll have a couple more videos in the future.